Hello and welcome to this video lecture presentation on exponents. We're going to look at what an exponent is made up of, how to solve them for multiplication and division, and how not to mistake them for the same procedures than when you have addition and subtraction with variables and exponents thrown in. So we'll talk about all that. And hopefully you'll get a firm understanding on exponents. All right, so here's an example of exponents here. I have this x to the fourth power. All right, so the x here is the base, and the superscript up here is the exponent. So what this exponent says is how many times we have to carbon copy the base by and multiply all those carbon copies together. So if I want, I could expand this out into x to the first times x to the first times x to the first times x to the first. So that is how we would expand this out. Now, since it's assumed that there's an exponent of 1, we could rewrite this into x times x times x times x. This and this are the same thing. So that's basically how an exponent works. So if I have 4 to the second, basically I need to take my base of 4 and carbon copy it by itself a second time, because 4 to the second expands out into the 4 to the first times 4 to the first, which we could solve this to give us 16. Now there is a very important distinction here between these two. Okay, let's look at this. Notice here I have an exponent of 2, and then in parentheses I have a minus and a 4. So what we have to do with this exponent of 2 is carbon copy all the contents that are in parentheses. So what this it's going to end up being minus 4 times minus 4, which I have two minus signs involved in multiplication. That will give us an even result or a positive result. And we're going to end up with minus 4 times minus 4, which is a positive 16, or just simply 16. Now for here, there is no parentheses. So basically, it is just 4 to the second. This minus is assumed to be multiplied to the 4. So if you look at the order of operations, exponents come before multiplication. So what this is going to end up being is 4 to the second, which is 4 times 4, or 4 to the first times 4 to the first, which is 16, and then we just chalk on the minus sign in front of it. So minus 4 to the second without any parentheses will give you a minus 16, while if you take a minus and a 4 and put it in parentheses and raise it to the second power, then you end up with a positive 16. So I really hope you understand that difference. Now here you can see if I have, say, x plus 2, and I'm not going to really solve it any further, but this idea here on whatever's in parentheses you expand out, that's what you could do here. And we're going to look at this later on. I just want to give you a little introduction here. So x plus 2 to the second, in order to solve that, it would be x plus 2 to the first times x plus 2 to the first. Then you would use what we're going to learn later on down the road to solve this even further. So that is how exponents work. Now if you look at multiplication and division, so say I have x to the fourth times x to the third. If you have common bases that are involved in multiplication, then all we do is we will add the exponents. So this becomes x to the 4 plus 3, or x to the 7th. For division, say I have x to the 9th over x to the 7th. If for multiplication, we add the exponents, For division, we subtract the exponents. So here, x to the 9th over x to the 7th would just give me x to the 9 minus 7, which is x to the 2nd power. Now, if we end up with, say for instance, I have a minus exponent, because this could easily be switched. Say I have a problem like this, x to the 7th over x to the 9th. We subtract this out, I get x to the 7 minus 9, which will give me x to the minus 2 power. Now, it's improper etiquette to have a minus exponent, so what we would do is, I'm going to assume that this x to the minus thirds multiplied by 1, and I'm also going to assume that it's over 1. You could do that with anything. Say if I have a 5, I could assume it's multiplied by 1 and divided by 1, and it's still 5. Well, same thing here. So if I have a minus exponent, and it doesn't matter if it's in the numerator or the denominator, an easy way to get rid of it is you just simply switch it over to the opposite part of the fraction. So if x to the minus 3 is minus on top, it will be positive in the bottom part of the fraction. So this will end up being 1 over x to the third. And that's how we would solve that. So to carry on with this problem here, we'll assume it's multiplied by 1 and over 1. So since x to the minus 2 is minus, you can bring it down, and we end up with 1 over x to the 2nd, and then you're done with that type of problem. Now don't mistake this. Say I have 4x to the 2nd plus 5x to the 2nd. Now this is addition, or combining like terms using addition. So what we would do here is we would just take the numbers in front called coefficients and add them or subtract them depending on what the sign is. So 4 and 5 is 9. And what we do for addition and subtraction is we keep the exponents the same. Keep them the same. You don't add them, because the adding of exponents comes when you're multiplying them. So when you're adding them, you just keep everything the same. And then you say, well, what if I have this? 4x to the 2nd plus 5x to the 3rd. Nothing you could do with this. They are not like terms. And we'll talk about that later on, because the bases have to match and the exponents have to match in order to combine like terms with addition. Okay, so that is how that works. And that will wrap up our discussion on exponents. Hopefully you found this video helpful to you and easily to follow and understand. Thank you for watching and listening, and have a good one. Bye-bye.